All right, let's go ahead and go through some practice problems of scientific notation. We're going to go from standard notation to scientific notation, and then we're going to go from scientific notation to standard notation. And it is super easy. So let's go and take a look at number one. Number one, what we're going to do is we need to take the decimal point and move it to where there's only one number to the left of the decimal. So what we're going to do is we're going to take the decimal point in this problem, which is right there, and we're going to move it to where there's one number to the left. And so we end up going 1, 2, 3, 4, 5, 6. And so what we end up with is we end up with 5.005 times 10 to the 6. Now, is it going to be a positive 6 or a negative 6? Well, it's going to be a positive 6 because it's a large number. Because we move the decimal to the left, it's going to be a positive 6. Now, let's go ahead and talk about number 2. Number 2, again, we're going to move the decimal to where there's one number to the left. Here is the decimal right here, and we're going to move it right there. And we will end up with 2.56 times 10 to the 1, 2, 3, 4. Now, is this a positive or negative 4? Well, again, this is going to be a small number. This is a very small number, and because we moved the decimal to the right, it's going to be a negative 4. So small numbers are going to give us negative exponents. Now, something I do want to state is that just because it's a negative exponent doesn't mean it's a negative number. It's definitely not a negative number. It's just a very small number. All right, number 3, we have a decimal point right here. We're going to move it to where there's one number to the left. We end up with 1.2 times 10 to the 1, 2, 3, 4, 5. And it's a positive 5 because it's a large number. All right, this is a really small number. So we are going to move the decimal point from here to there. And so we end up with 1.25 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that is a negative 12 because it is a small number. And so that is the answer for that one. Now here we have scientific notation. We're going to go the other way. And what we're going to do is we're going to take the 6.02 times 10 to the 4 and convert it to standard notation. Now, the 4 tells us how many times we're going to move the decimal point. However, are we going to move it to the left or are we going to move it to the right? And the way we answer that question is, well, because it's a positive 4, because it's 10 to the positive 4, are we going to end up with a large number or a small number? Well, we'll end up with a large number. So if we moved the decimal point this way, would that give us a large number? It wouldn't. And so to get a large number, what you need to do is you need to take that decimal point and move it to the right. 1, 2, 3, 4. Now these empty spaces here, what we do is we add zeros. And so our final answer is going to be 60200. So notice how even though it's times 10 to the 4, it doesn't mean that we have 4 zeros at the end. What it means is we moved it 4 times. So this is our answer. Now this next one here, we have 1.25 times 10 to the negative 5. So because it's a negative 5, we're going to end up with a small number. If we move the decimal to the right, that would give us a big number. So to get a small number, we end up going to the left. And we have 1.25. We go 1, 2, 3, 4, and 5. And we end up with 1, 2, 3, 4 zeros in the front of it. So we end up with 0.0001 0, 1, 2, 5. So again, we have 4 zeros in the front. The first digit that it moved through was the 1. So something to keep in mind, and we box our answer here. Now the next one, it's a positive 7, so we're going to move it 7 times in a direction that is going to give us a big number because it's a positive 7. So 1, 2, 3, 4, 5, 6, 7, and hopefully you're starting to kind of see a pattern here. We're going to end up with 1, 2, 3, 4 zeros. And we get 5, 2, 4, 7, and then 1, 2, 3, 4 zeros. And that's our answer there. And then this next one, 1.2 times 10 to the 1. We're going to move it over 1 time, and this essentially equals 12. And it's that simple.